Hello guys, welcome back. Algorithm analysis. Why we need to analyze the algorithm? We want to predict how the algorithm will behave. Example, running time on arbitrary inputs and how it will compare to other algorithms. For this purpose, we use to analyze the algorithm. Second, we want to understand the pattern behavior or pattern behind the behavior of algorithm. Theoretical analysis as well as the practical analysis. To analyze an algorithm theoretically, we break down the algorithm in a high-level primitive operations independent of programming language and the platform. High-level primitive operation meaning it is independent of a programming language and the hardware configuration and the platform, etc. Such as assigning a variable, performing an arbitrary operation, comparing two numbers, etc. A primitive operation corresponds to a low-level machine instruction. The time of the operation differs a little by a small constant. Basically, an operation may take between a few clock cycles to 100 clock cycles or so. For the purpose of our analysis, we consider that all operation takes the same amount of time. To analyze, we count the number of operations. This will be our estimate of running time. The formal name of this is a RAM model. RAM model is a random access machine model. Instruction executed sequen- sequentially at one at a time. All instructions take a unit time. Load, store, arithmetic, logic operations. So all the operations takes a unit of time. Main memory is infinite. The running time of an algorithm is the number of instructions it executes in a RAM model of a computation. RAM model not completely realistic. Example, the main memory is not infinite, or not all memory access take the same time. Not all arithmetic operations take the same time. Instruction pipelining, other processes. So RAM model is just give the tentative analysis of algorithm and it is not the realistic. It may differ based on the following reasons. Already I have uh, told main memory is not infinite, the memory access not takes the same time, all those things. But RAM model is a good enough to give the realistic is good enough to give approximate result of the analysis. So for that we used to go for theoretical analysis like a RAM model, right? So here we are interested in running a time function. We are interested in running a time function as an input size and usually generated by n. Analysis of algorithms is very much a crucial aspect in developing the software. Example, you see, running time of a sorting algorithm is expressed function of n equals number of elements in the input array. Not always possible to come up with a precise expression of running time for a specific input. Example, running time of insertion sort on a specific input depend on that input that we interested in. Here we have two cases. Best case, worst case, and three cases. Best case, worst case, and the average case. Best case is the shortest running time of any size input in. The algorithm will never be faster than this. That is the best case. Best case means what? The algorithm have the optimal performance of the algorithm is called the best case. Worst case, the longest running time of any input size. The algorithm will never be slower than this. Sometimes we might also be interested in the average case also. So best case, average case is this average running time. Okay, best case is the optimal performance of the algorithm. And the worst case running time is a maximum, very worst running time. That means it takes enormous time to execute a particular algorithm. And the average case is the in between the worst case and the best case is the average case, right? And moreover, we need to take care that average over what? Average case means what? Average over what? Must assume the input distribution unless otherwise specified. We are interested in worst case running time. WCRT gives us a guarantee for some algorithm. Worst case occurs fairly often. Average case often as bad as a worst case, but not always. So these points you need to take care. So in analysis of algorithm, in time complexity or space complexity, we always concerned with the worst case, right? So it is the maximum amount of time taken to execute the algorithm or maximum space it occupies. So this is how we are concerned with the analysis of a algorithm, right? Okay guys, see you, bye bye. Have a great day.